So my name is Nathan Kurtz. I'm a scientist at NASA Goddard Space Flight Center. So my background, though, I grew up in Southeast Iowa, a small town called Fort Madison, Iowa. My dad is a railroad engineer, was the Santa Fe, turned into BNSF. So he was always heavily involved in union matters. So I always heard a lot about union matters from him. I went to school at Iowa State, so I majored in physics. And then using my physics background, I was able to move out to Maryland for graduate school and get connected with NASA and the broader research that NASA is doing. I have several different roles that I play there. One of my roles is it's called the lab chief. So I run the cryospheric sciences lab within NASA. I also have another hat where it's called the deputy project scientist. So we're managing a satellite mission. It's called the ICET-2 mission. So ICET-2 stands for the Ice, Cloud, and Land Elevation Satellite. And it's the second version, so to speak, of that. It's a laser in space using a laser, just measuring the round trip time between when a laser is fired and hits the ground and bounces back up. You can measure the height of the surface very, very accurately. And so we use that to study changes in the Earth's system, especially looking at things like the atmosphere, vegetation, and then I specifically study ice. So especially ice that's floating in the ocean called sea ice. So within the cryosphere itself, there's really two different aspects that we're seeing. So the first is that there's ice on land in places like Greenland, Antarctica, and mountain glaciers. And that ice is melting, especially in places like Greenland in particular, are melting quite a bit. And so when that ice melts, it goes into the ocean and it raises sea level. And so we're able to measure the direct contribution of the melting of the ice to sea level rise. The other thing that we're seeing is that the ice in the oceans, especially in the Arctic, is melting. So the Arctic sea ice is decreasing quite rapidly in the last few decades. It's about half as thick as it once was, say, when I was born about 40 years ago, and the extent is shrinking. And so what we're seeing is, the trend towards the Arctic is that we will probably see what's called an ice-free Arctic within, 20, 30, 40 years, something along those lines. So, within the lifetime of hopefully me, but and also for my and our children. So the impact of melting sea ice really impacts our ocean and atmospheric circulations. So part of what sea ice does is it influences how much energy is transferred between the ocean and into the atmosphere. And the Earth it's a big system. The way that the atmosphere circulates, the way that the ocean circulates, again, it's this big interconnected system. And so if you start changing one piece, meaning you're changing the energy balance at the poles, it can start to impact the entire global circulation. And so what we see are that there are impacts to people here, like in the mid-latitudes, from that melting sea ice. In addition to changes in ocean circulation as well, the sea ice really drives what's called the deep ocean circulation. So both in the Arctic, but especially in the Antarctic, the sea ice cycle, when sea ice melts, it releases salt into the ocean, and that salt makes the surrounding water heavier, and that sinks all the way to the bottom of the ocean. And so it's for that reason that we actually have a deep ocean circulation. You can actually have life at the bottom of the ocean because that sea ice is helping drive this deep ocean circulation. It brings things like oxygen and nutrients down to the bottom parts of the ocean that otherwise wouldn't get that. The Arctic is warming about 4 times the rate of the Earth as a whole. And the reason really is because of that loss of sea ice that I spoke to. So sea ice, especially sea ice that collects snow on it, it's bright. So when the sun is up in the summer, if you have that sea ice covered ocean, the energy from the sun, it hits the snow and it bounces back into space. So actually that sea ice helps to cool the planet. But what you get with the melting sea ice, it exposes the ocean, which is pretty dark. And so then you go from a system that's reflecting a lot of the sun's energy back into space to a system that's absorbing a lot of the sun's energy into the ocean directly. And so it warms the Arctic much more than the Earth as a whole. Really, it's the pace that's worrying. The pace of these changes is quite rapid. And then also, I mean, we don't know what's going to happen to things like the ecosystem, or even things like the ocean circulation. You know, we can try to model it, we can try to guess, but ultimately there's always some uncertainty. And so we want to make sure that nothing catastrophic is going to happen to us that we can't prepare for. And so that's what we're trying to learn, so we can prepare for changes. I mean, there are changes that are locked in. I mean, these are going to happen. And if we continue emitting greenhouse gases, those changes will be magnified. If we emit less, then they'll be less magnified. So again, can we understand these changes and what we're bringing, and can we prepare for them? I have to say, I mean, I understand that sense of futility. I've flown over the Arctic, the Antarctic. I've been to both poles. I mean, I've seen the scale of, you know, the polar regions in general, and it's massive. And it's, to some extent, like, it's hard to wrap your head around how could, you know, we and what we're doing as a society, you know, be affecting these far-flung places, and you know, to the degree that we are. And these are such massive places. How could we have such an impact on them? You know, that's one aspect. The other is, I mean, okay, so then, you know, what was it that we can do? And it, you know, it comes down to understanding the science, which is just that the greenhouse gases trap the sun's energy. It traps a certain amount, and, you know, by building things like models and such, we can understand to a degree what that's doing. And so, I mean, there has been a lot of modeling work, things like that, to try to predict, you know, if we change our emissions in a certain way, you know, what will be the impact? And the results do show that if we did cut emissions, you know, starting now, and then into the future, that we could have real change. It's not completely futile, but it does involve cutting emissions. Bottom line, that is what it comes down to. And how fast we can cut emissions, how much we can cut emissions, and how we do that.